Welcome, everybody. Um, I'm Phil Miller, and I get to lead a lot of the products that we make at Chaos Group. In case you don't know, Chaos Group, we're the makers of the V-Ray and Corona renderers, as well as Phoenix FD for fluid simulation, and now Project Lavina, which we'll be talking mostly about today. In doing so, we serve really artists across both the design and visual effects industries. We almost 50-50 across whether they're making motion pictures or visualizing the latest and greatest buildings and cities. At the same time, we also help developers build their own applications that then employ our technology. We have SDKs that allow V-Ray, for example, to be included in everything from a design application to a car configurator, for example. So a lot of the things that we'll be talking about today they'll definitely be applicable to the end users, but they might also be applicable to people doing more serious or enterprise gaming. Our mission really is to solve the hard problems so you don't have to. We've been talking a lot today about a lot of the technology and how you can employ it. We're really about creating ready-to-use solutions that you can employ right away. We're always looking into the latest technology. We love to play with new hardware, and in doing so, we try to find the things worth solving. And that led us to creating what we call Project Lavina. Now, we debuted Project Lavina last SIGGRAPH as a product, and it's going to be Chaos Group's first standalone product, really for the exploration of scene content that's been made in other applications in a completely fully ray traced real-time environment. We began beta with customers in January of this year. Later this month, it's going to enter what we call a wide beta, as it gets a lot more functionality with workflows that are going to make it ideal for architectural pre-visualization. So you'll get a sense of that a little bit later here. Now, if you noticed, we're talking about 100% pure ray tracing with Lavina. Other talks today have talked a lot about hybrid ray tracing, the combination of ray tracing and raster. We actually take a different route on this because we're looking at the overall workflow for people, not just the visual result. Obviously, pure ray tracing delivers the highest level of quality. We show that in our V-Ray renderings, like for example, this one done here. It's also a lot easier to use. If you are treating the world the way it actually behaves, with all behaviors of light and materials, then it's actually easier to author for. You don't have to think about computer graphic techniques. You simply think about the way the real world works. The other thing is that you don't have to do baking because all the lighting is dynamic. And if you keep everything in ray traced, then we get to use the same approaches. We don't have to suddenly go, okay, now we have to switch between what was ray traced and fake that with maps or whatever, because we're now trying to take a ray traced shader and turn it into a rasterized shader. None of that is needed. We can keep it all very consistent. The other nice thing about ray tracing is that performance does not go down when you add geometry. As long as you have memory, your performance is going to be fairly consistent for the resolution that you're presenting at. So for scenes that are highly complex, for a given resolution, ray tracing can often be faster than rasterization, especially for complex big models. Now, we've been doing GPU acceleration at Chaos Group for quite some time, over 10 years, in our V-Ray GPU renderer, which is the most fully featured renderer for production use. But we knew that if we wanted to go real time, there was no way that we could bend the V-Ray GPU to do that. What we needed was having a dedicated solution for real time. So when we found out what NVIDIA was doing with their ray tracing hardware with RTX, we started the Project Lavina concept with this in mind. So We knew early on that the RTX hardware really varies according to how much shading is going on in the scene, how much work your renderer is spent raycasting versus shading. And on the scene on the left over here, you can see that nearly 60% is actually in casting. That blue section then is what the RT cores on the RTX chips accelerate, but it doesn't help at all with the white section. On a heavy visual effects scene, for example, that could actually just get flipped. Well, if we take something that took 10 minutes a frame and knock off 40%, maybe that goes to 0 with acceleration, we're still off with 60%. So it far, far short of real time. So the more simple we can get the shading, the greater the amount is spent in casting and the greater benefit we can get from the hardware. So we took a look at this and said, well, what if we just concentrated right on that section and built a renderer that tried to do as much as possible there and as little shading as possible so that we can maximize the benefit that we're getting from the hardware that we knew was going to be coming. And that's what the genesis for Project Lavina was. So in case you're wondering, the word Lavina is actually Bulgarian for avalanche, because we thought this was a groundbreaking technology that would really usher in new possibilities. Our goal, of course, was that real-time meant real-time. We'd be going over 24 frames a second, and that we'd be doing it entirely with ray tracing, no rasterization whatsoever. This gave us the benefit of working with original data, and also big data. If you can author it in your creation application, we can render it with Lavina. That was going to be the goal. Also, the workflow could work with any of the things that already worked with V-Ray. V-Ray is integrated into 10 or more products, and all of those products would be able to work with Lavina using the workflow that people already knew and had. In doing so, we believe that we've created the fastest route to real time for original data. So if you're a designer or even a visual effects artist, you want to see your work in real time, we'll get you there faster than anybody else, we believe. So the actual speed up that we've been getting with Lavina has been quite good. So the actual speed up of the Turing versus Pascal architectures was a traditional increase of about like 30%, but we're seeing about 5 to 6x faster between generations. And this is entirely due to utilizing the RT cores on the RTX chips. As luck would have it, one of our customers that was an early beta tester of Lavina happened to do a promotional video with both NVIDIA and Lenovo this week. And here I have an excerpt from this because they actually highlight the use of Lavina in one of their projects. So Nuscape is one of our long-term customers for V-Ray. They specialize. Of course. Can you hear me now when I'm talking?
Yes.
You can. Okay.
Yes.
Okay, because I was wondering if that would get blocked. So they had this incredibly difficult project, which was the largest doing basically ride films for people going to the largest observation deck in North America. And they needed to visualize all of this, all the angles with an enormous data set, which was basically all of downtown New York. And then they brought into Lavina when it was very young. This was even before Christmas. They were doing a lot of this work. They then what they would do is take all the decisions they made in Lavina for lighting and camera placement and even transition, and then they would bring that back into 3ds Max, where they would actually do the final renderings in V-Ray. What we had Carlos here talking about is the fact that it didn't break, which is kind of an interesting testimonial. But mainly he was saying that because this was, alpha software, and it was handling enormous data sets. And we can get a little bit more detail on that here. So this is actually a screen capture of them using Lavina. And you can see here, whoops, going back. You can see here that it's really about the entire downtown of New York. This is all within Lavina. This is all real time. 510 square miles of New York City, all inside, ready for visualization. Now you can't see the detail here. We go to a closer view, and you can really get a sense for just how much data is happening here. So this is the final output from Lavina, 130 million unique faces, over 3 billion of them when instanced, all running within standard GPU memory, a little bit under 24 here. So it fits within the 6,000 cards that they were using. You can get a sense for all the instancing going on by all the vegetation and also the cars and the people. All those are not unique, but they're all being rendered and all, being visualized in a way that they could otherwise never have done. So we proved at a CAS group that you could do real-time ray tracing about 5 or 6 years ago with a project called Construct, where we did motion capture and used a cluster of GPU machines to actually render that in real time. Of course, it was noisy, but today you can now do that on a single RTX card with Lavina and with much higher fidelity. So we like to say that we went from $250,000 to $1,000 in 5 years, which we think is a great potential for all designers and artists out there. So this is what Construct looks today in Lavina. I did a quick screen capture of this this morning on my system. As you see, we bring in the characters. These are just completely output right from Maya, as they actually from 3ds Max. Within here, we can change cameras while the animation is running. There was nothing done to the scene to bring this in to Lavina. It was just simply exported and was ready to go and be visualized. What's a little different is that you actually get to create and change your cameras while the animation is playing. You can make a lot of artistic decisions, almost like walking around with a Steadicam as you're working. And this is what we're finding people are loving about working in a fully ray traced environment, is that they get this level of realism without actually any work. So none of the actual use of having to go to low poly or modify any of your shaders. It all just comes in and works the way you had authored it in your creation tool. Okay. So under the hood, we've been talking a lot about how things work today. Lavina works with DXR. So it's using the ray tracing extensions for DirectX. We also have our own denoiser that is also implemented within DirectX, so that it's all self-contained there. And we're also supporting dual GPUs. What you saw me running on was a pair of GTX RTX 2080s. It is 100% ray traced. Everything you saw there was entirely ray traced, no rasterization at all. It's just supporting a great deal of the V-Ray capabilities. So you can make critical decisions about your lighting and your camera with very close to final shading results that you are then able to secure for later work. So this leads us to the fact that we need to round trip actually back to the creation tools. And that's something that's going to be coming to Lavina later on this summer. Another one of our customers is Brick Visual, and they've also been using Lavina extensively. And here is a video of their use where they are showing how they are using Lavina and then comparing that right with their normal V-Ray output. So these are all projects done in Lavina. Everything you're seeing here at the beginning is 100% coming from Lavina. Even this massive city, which they were able to easily navigate with in real time. Here is that same city within the Lavina interface. You can see all of the lights on the right-hand side. Lavina can handle hundreds, if not thousands, of lights, and without a problem. Now we start comparing what Lavina looks like against standard V-Ray, and you can see that it's actually very close. So while we concentrated on making Lavina use as much raycasting as possible, we're still able to get a high level of quality, especially for matching what the final V-Ray does. Here, for example, that looks really good. When we look to V-Ray, now you get the motion blur and everything that you needed it for. But clear case example of Lavina already being used in production while it's in early beta. Okay. So as you look at our solutions from Chaos Group, we have V-Ray for many products. Everything in blue there will actually author and output to Project Lavina today. So if you were to get on our beta, you could use your choice from Cinema 4D to SketchUp and output to Project Lavina. Here's another one of our examples from one of our customers. This is Bertrand. He has his site BBB3Viz where he sells his models. You might have seen one of these. But now let's take a look at what this really looks like when you bring it into 3ds Max. So in 3ds Max, this is what this model looks like. If you get rough ideas, it's a pretty big model. It's about 15 million polygons. You can navigate somewhat, but it's still pretty cluttered. You can't really see what is going on. I come over here to the left-hand side, change it to a camera view. I can see a lot of going on there, but it's really not the best for understanding my composition, especially because a lot of things only happen at render time. So now I come over, here's the exact same scene in Lavina, running at the same time. There is no more guesswork. I know exactly what I am doing as I'm walking around in a fully ray traced environment that just doesn't care about how many polygons you throw at it at all. As you can see, what were just clumps before over in 3ds Max now are completely detailed because we have just baked all the geometry. What is normally only done at render time, we actually do completely on the export. One fascinating thing is that this model, the time it took to load this model in the 3ds Max was about 3 times longer than it took to export and load it into Lavina. So very efficient loading. You can see we have over twice as much unique triangles as was in the Max model and many more instanced. Here to give you an idea, here I go and select the objects in 3ds Max to give you an idea of like how dense the geometry is. I come back over to Lavina, go into a selection mode, and now suddenly you can see every blade of grass, every pebble is on there as individual objects, and they are all because they were massively instanced in the scattering tool, and those are all now actual geometry in Lavina, and the performance in Lavina just doesn't care. It just keeps on going at full performance. So that's why we're getting a lot of use of Lavina already in beta, because it's delivering something that people otherwise just don't have. Also, while we assume that you have an RTX card with Lavina, in many ways we start thinking about rays being free because there's so many of them to use. So obviously we're doing ray tracing entirely, but also we get automatic collision detection. It's nothing to shoot dozens of rays to see where our collisions is. So we can walk around and bump into walls. We have automatic ramp and floor discovery, essentially by casting rays. Depth of field is all ray traced. Hit testing, everything I was doing on selection, that's all casting rays. Rays are free. We make use of that for a lot of things that are usually done with other approaches, from collision detection to floor and ramp detection, to even hit testing when we make selections with the mouse. We can select 10,000 objects in a microsecond through the ray tracing. It's quite nice. Also, instead of doing traditional overlays with raster, we're actually ray tracing them as well, which gives us the nice ability to actually warp things when the camera lens warps as well, something that you don't normally get when working with design applications, for example. So on our beta, we're introducing a lot of features. This is an example of one of those. This is just an example of one of the videos for our beta program right now. We do videos with every single release. This one is introducing the concept that we've introduced IES lights in this release. So we're just going through, showing you with a real world example, and coming inside and starting to show the use of IES lights. Things are now so fast that it's it becomes like an IES previewer of what your shapes are going to look like by quickly just going through the different options and then landing on the one that is giving you the right result. But that's just an example of the resources available to you in our beta program. So everyone's invited to the beta. If you have an RTX card, then you and basically any type of V-Ray workflow, you can use Project Lavina, and it'll use the same render license that's already running on your machine for V-Ray. So it's all ready there for you. Just come to chaosgroup.com/Lavina, and you can download it immediately. Then we, of course, would love your feedback on our forums. It is quite capable today. You can actually even do scene merging. You can, of course, save cameras, set up camera animations, hide unhide selections, replace materials, adjust your lighting, do all the HDR lighting as well, all there. More capabilities will be coming later this month. In our direction, we're really taking, people have been telling us what they want to do with it. This was one of the situations where we had something that was really cool technology and we wanted people to experience it and tell us what they wanted. And these were some of the top things that people were doing with Lavina right from the beginning. And so that's leading us to investigate the next steps for Lavina, which are one of the top ones is bringing decisions back into the animation tools. Also supporting VR directly from Lavina. People want to start experiencing things in VR in a fully ray traced environment. And then also even possibly invoking a V-Ray right from that environment as well. So that's what we're working on. We think that the world is in an incredibly exciting place with ray tracing hardware, especially affordable now. And you'll be seeing a lot of solutions coming from Chaos Group as we're a dedicated company to ray tracing. So we can open it up for questions.
Great. Thanks so much, Phil. There was a question that came up. Is Lavina used in any upcoming game or console or PC?
No, Lavina is really a standalone application at this point. We have designed it, the Lavina renderer that is, in a way where we have the option to possibly move it to other applications directly. So it could be something that you see in the future, but right now it is only within that application. One of the things that we're being asked a lot of is can people have a headless one where they can start to, like, for example, build a configurator around it or something like that. And that is also something that we're looking on to hopefully have something to start with later this year.
Okay, great. And then, great. There's another question. Is it cloud only? I went to Project Lavina website and it seems to be for the cloud.
Oh, that seems, we need to get better on our messaging. No, it's a client application. So it runs completely on your machine, uses up to 2 GPUs, and it's definitely as thick client as you can get.
Okay. Really appreciate it, Phil.